Today we're going to look at the last of the tests, and this is oftentimes just listed on the IB exam. It just tells you, do this test. It doesn't tell you to just see if series converges. It'll tell you, use the comparison test. This is kind of like an island separated from limit, ratio, and integral test. This is something that I will tell you when to use, and IB usually tells you what to use. And if we do this from before, remember when we did the areas? We went from like 1 to infinity of u of n du. We did the areas. I think we used, it would be f of x dx. Remember when we did that? And you picked an area, one that you understood. If the small one diverged, what will the big one have to do? The small one diverges, the big one diverges. What if the big one converged? What will the small one have to do? Converge. So we've done this already, this part. But you can do the same thing with series if you want. You can look at the series and just figure out, okay, if you have two series and you know that one of them is always less than the other, you can say, oh, the small one converges, or the large one converges, so the little one will converge too. That's a way of doing the test. You're kind of familiar with that. For example, if you looked at this one, 1 plus 1 over 2 squared, 1 over 3 cubed, 1 over 4 cubed, that is always going to be a little bit what to 1 over 2 to the n? Well, this could be 5 to the n, 10 to the, or this could be 5 to the 5th, 10 to the 10th, 20 to the, and this one can only be 2 to the 10th, 2 to the 100th. This one will always be a bigger denominator, so it'll be smaller, right? So do you know if 1 over 2 to the n converges or not? 1/2 plus 1/4 plus 1/8, does that converge? Oh yeah, this one converges. Why? It's geometric, right? Right? So if this one converges, then this one will have to converge too. That's what we did before. That fits that paradigm pretty well. But you know what? There's a way better way to do it. And we're going to do that right now. This is the improved comparison test. This is what you'll want to do when you do any kind of a comparison test. This is the one you're going to want to do. Here goes. So you're going to take a series that you know, and you don't have to find out whether one of them converges or not, okay, right away. All you have to do is take a ratio. So if you take the ratio of the one you don't know compared to the one you do know, so it's going to help to know a few of these. If you take that ratio and you get a constant, okay, any constant other than 0, you're going to be able to say that they both converge or both diverge. Now this is different, but it's actually pretty efficient. So if you know that something converges and you do this ratio, take the limit that n approaches infinity, and you get a constant other than 0 or infinity, then you're going to be able to say they both converge or they both diverge. If the bottom one converged, then you'd say the other one converges. Only if you get a constant. So if we took this one down here, you would say, all right, limit n approaches infinity of u of n, 1 over n squared minus n, over 1 over n squared. Well, I know 1 over n squared using the p-test. What's this thing going to do? 1 over n squared. Converge. P is greater than 1, so this one's going to converge. I know that. But when I do this limit, n approaches infinity of n squared over n squared minus n, what is that limit going to be? 1. And that's a constant. And that tells me, using this comparison test, that both converge or diverge. Otherwise, you don't know. If you get 0 or infinity, you really don't know. Then what I would do is I would say, oh, using p-test converges. So if this one converges, then the other one, both are going to converge. Mm-hmm.
On a test, you would say, like, therefore, since limit as n goes to infinity of u of n over v of n.
Yep. So take a look here. U of n and v of n be a series such that u of n is greater than 0 and v of n is greater than 0. So what we would say, therefore, since both series have positive terms and the limit, I'll move this up here so you can see, the limit as n approaches infinity of u of n over v of n is equal to 1, and v of n converges, if you want to say by p-test, then u of n converges by comparison test. Here's just a quick little added thing with the limit comparison test. We talked about having the two series with positive terms. You've got to mention that. And then if you get c greater than 0, what if you get 0? Well, if you do get 0 for a limit and the one you know converges, the other one will converge. If the one you know goes to infinity and diverges, if you get infinity and then the one you know diverges, the other one diverges. So this would be a nice thing to kind of save on a cheat sheet using the limit comparison test. Do a quick problem here. This is 1a. Let's say I did 1 over e to the 2n. How is that going to compare to e to the n? Bigger or smaller when n is greater than 1, greater than or equal to 0? Greater than 1. Will this always be bigger or smaller than this one? Smaller, yeah. So take the limit, n approaches infinity, all terms in both of them positive. Good. Limit as n approaches infinity of, okay, we're going to take 1 over e to the 2n, the one we don't know. 1 over e to the n is the one we do know. So this is going to be e to the n over e to the 2n. What is that going to be? Simplified. Yep, 1 over e to the n. And that limit is going to go to what? 0. Yep.
Do we even have to say the, oh, yeah, the first part, the
Mm-hmm.
1 over, no, yeah, we even have to say that?
This part?
Yeah.
Absolutely. For the comparison test, you do not. And that's kind of the beauty of it. You don't have, this is optional. You don't have to have this. That's right. Yeah, and so you don't need to put that in there if you don't want. But just get one that you do know. I know this one. Okay, that one's going to converge. All right, so therefore, since both series have positive terms. Yep, all positive terms. And the limit as n approaches infinity of un over vn is equal to 0, and v of n converges. Therefore, u of n converges. I would say by integral test, if you wanted to do that. U of n converges by comparison test.